Very simple. You just what do you say? Plot the graph between stress you plot on the y-axis, strain you plot on the x-axis. Initially within proportion limit. What a proportion limit, children? I am asking you straightly without what is the proportional limit? Means stress is proportional to strain. Kindly say yes or no. I mean within the proportional limit it will obey the linear relation. Correct or wrong? Kindly say yes or no. Stress if you treat like a y and strain you treat like a x. What kind of graph you got, children? Straight line graph only, no? I mean if you double the mass, if you attach double the mass, strain also, I mean double elongation taking place, na? 1 kg you attached, 1 millimeter elongated, 2 kilogram attached. Logically, how many millimeter it will elongate? 2 millimeter only, na? Say yes or no? Such limit only called which limit? Tell me. Proportional limit A. And within the proportional limit A, if you remove the block, again string it will go back to its original shape and size. Understood? Means still elastic forces are alive in the string I am telling. Are you understanding, children? Now, that's what such point is called point A. But if you see between A and B, what is happening? Between A and B, what is happening? If you will put very less mass, 1 kg, 1 kg, 1 kg you are increasing, na? If you put 3 kg, how much elongation do you expect? If proportion limit is validating, how many millimeter you will expect, children? Tell me. But here 4 millimeter you will observe, or 5 millimeter you will observe. Why, children? Tell me. Initially the wire is thick and very strong, but as it is getting elongation, what will happen? The gap between the molecules will increase. Will increase means attraction force between the molecules also will decrease. What will happen, children? If you attach 3 kg block, the molecule is unable to carry the below molecule because the gap is more. That's what instead of 3 millimeter, it will elongate more. Are you understanding my point? That's what, if you notice from A to B, the line become curve. Correct or not? Here less stress only there. I mean very less mass you attached. But what did you notice, children? More elongation is there, na? Kindly say yes or no. That's what the, what do you say, the curve, I mean the straight line become curve here. But till point B, even though if you remove this 3 kilogram block, still the wire will go back to its original shape, I am telling. Are you understanding my point? I mean, here I will remove the 3 kilogram block. Even though 3 kilogram block is not satisfying proportional limit, but if you remove the 3 kilogram block, it will go back to its original shape and size. Means still elastic limit is there. Are you getting what I am trying to tell? Understood? I mean B till B, it is B is called which limit, children? Tell me. elastic limit. Am I very much clear? Is my point very much clear, children? Proportional limit we will call. And you have more masses. If you have more masses, I mean 3 kg you attach. Next from B to C I will analyze. B to C behavior somewhat unique and different. I attached 5 kilogram. I attached. What do you notice, children? Already it is thin and very much thin and no? Correct or not? And still you are applying more and more masses. What will happen, children? Up to some time only it can tolerate this stress. Are you understanding? Correct or not? As you are attaching the masses, elongation taking place. If you attach 7 kg, still elongation taking place, but I mean abnormally it will behave. Are you understanding? That ending point is called yielding point. What the name of this point, children? I mean B to C, if you attach mass, B to C, what will happen? Tell me, children. If you attach mass, still what taking place? Still elongation. I mean the wire is doing its job. I mean example I will tell. If you attach 10 kilogram block, it will elongate 50 millimeter. Understood? So for this also some limit is there, no? So such limit is only called which limit, children? Yielding point or yield limit. Then C to D after C to D, if you see C point to D point, children, somewhat completely the wire will have some completely peculiar behavior. Peculiar behavior means you don't need to apply any mass. Why, children? Already it is thinned like anything. Understood? Like hair like structure it happen already. So you don't need to attach any mass. Naturally it's due to its own mass it will elongate. How you know that when you are making gulab jamun, that gulab jamun sweet syrup is there, no, children? Have you noticed sweet syrup? To check the consistency, what your mother will do? She will put her fingers inside that sweet syrup and she will check we can insert gulab jamuns or not. What will happen if she lift the finger? What will happen? Due to its own mass only, the syrup will elongate, no? Have you noticed that? Honey or sweet syrup? Kindly say yes or no. You don't need to attach any mass. Due to its own mass only, that sweet syrup or honey syrup will elongate it due to its own mass only, no? Same behavior your wire also will perform. You don't need to apply any external stress, but still it will continue the uh, elongation. Is my point clear, children? Such behavior is called what here behavior? Plastic behavior. Plastic C today they will show plastic behavior. Plastic means immediately in your mind plastic bucket mugs will come, not that substance I am telling. What the meaning of the plasticity is a phenomena. What the meaning of plasticity? Reverse phenomena of elasticity. What is the elasticity, children? You applied some force. When you apply the deforming force, if you take rubber band, it will elongate. If you remove the deforming force, what will happen, children? It will go back to its original length and shape, na? Kindly say yes or no. So such phenomena is only called what? Tell me. elasticity. Then what is the meaning of the plasticity? You don't need to apply any deforming force. Automatically it will elongate, no? Correct or not? Can it come back to its original shape and size? No, no. Example, you take one uh, parota dough. Parota, you ate, no, everyone eat, no, parota. After doing, it will increase its size. Can it come back to its original shape? Can it come back, children? So means it is having plastic behavior. Even though you remove the roller on its surface, it cannot come back to its original shape and size. Understood? You take one parota dough or wheat dough like this. What will happen due to its own mass? It keep on elongating, na? Correct or not? Can it come back to its original shape and size? No. So means what behavior it is performing, children? Plastic behavior. Permanently it will be in that same state only. Even after no deforming forces were applying, but it keep on changing the shape and size only. So either shape or size. I am here size only changing. Shape you don't need to bother. But it is. Do you think it is permanent? Throughout its lifetime, it's keep on elongating. At some particular point, it will fracture. No, to break off. No, it will cut into two pieces. No, children. It is yes or no? If you dip your fingers in the sugar syrup or honey, that honey stick to your finger, it keep on elongating. But at a particular point, what will happen, children? It breaks into two pieces. No, kindly say yes or no. Say yes or no. Such point is called what, children? Tell me. Fracture point. Correct or wrong? Fracture point. So finally, D will come to and ending with the E. So our discussion is over. Is my point clear, everyone? Is everyone understood the stress and strain curve nicely? Nice. Understood? Okay. Just copy down this curve quickly. Shall I move the slide, children? Okay, so now immediately once tell me what is our title of this chapter. Respond. Elasticity. I mean, within elastic limit only we have to confine our discussion, children. So I will state Hooke's law. What is the Hooke's law? Within elastic limit. Within elastic limit. What did you notice in all the cases, children? Stress is proportional to what here, children? Strain only, na? Kindly say yes or no. Stress is proportional to strain. I mean, to give a perfect equation format, so I can write stress is equal to, I will put any constant called any elastic modulus I will keep, that is nothing but this one. So I can write elastic modulus equal to how much, children, tell me? Stress divided by strain. What are the units to measure the strain, children, tell me? This one. Hmm. And so here, so you can write this E is nothing but elastic modulus. Elastic modulus. Is my point clear? So one by one I will explain. There are totally three types of elastic modulus are there. First of all, Young's modulus of elasticity or Young's modulus. Young's modulus, that is denoted with the symbol capital Y. You just see one example, children. This is one original wire of length L0, and you pulled with some force F Newton. You are pulling wire is pulling the rigid support with F Newton. So wire also pulling rigid support also. For every action there is an equal and opposite reaction, na? So support also pulls the wire with equal and opposite force. What I mean to say is the wire will experience totally how many forces? F Newton downside, F Newton upside. What is net force acting on the wire, children? Zero. Individual forces are there, but net force equal to how much, children? Zero only. Correct or not? Yes or no? So you can define Young's modulus as longitudinal stress. Longitudinal stress and divided by what here? Longitudinal strain. Longitudinal stress by longitudinal strain is called as Young's modulus. Correct or wrong? So I can write longitudinal stress. What we can write, children? Applied force by applied area of cross section of the circular cross section by what is the longitudinal strain, children? Tell me. Change in the length by original length. So Young's modulus I can write F into L0 by A into change in length. Say yes or no, children? This is nothing but Young's modulus. Force into original length divided by what is the area of the circular cross section? Pi r square into change in the length. This is the Young's modulus. If you observe, F is nothing but a deforming force. So you can write applied force equal to Y into A by original length into elongation. Watch this equation properly, children. It is nothing but it is looking like F equal to K into X only, no? Within the elastic limit, how wire behaves, children, tell me? If you attach one block, it will elongate, na? If you remove this block, what will happen, children? It will go back to its original shape, no? Same behavior is performed by spring also, na, children? Kindly say yes or no. If you attach a block, what will happen? Spring also elongate. Say yes or no. If you remove the block, what will happen? Again it will go back to its original shape and size. I mean, I can write one statement: within proportional limit, or elastic limit, within proportional limit or elastic limit, within proportional limit or elastic limit, tell me, children, what will happen? String behaving like a spring only, na? Kindly say yes or no. String behaves as a spring only, na? So I can write F equal to K into X. X is nothing but elongation, I mean change in original length. And what is the force constant? Here K is called spring constant, or you can also call it as force constant also you can call. You can call it as which constant, children? Force constant also you can call. Force constant also you can call. Force constant formula how much, children, tell me? Ya by original length. Everyone should remember compulsory at your fingertips. Is my point clear, my dear children? Correct or not? And if you elongate the spring, work done by you stored in the form of elastic potential energy only, no? So someone tell me what is the elastic potential energy stored in the string, children, or spring? Elastic potential energy stored in the spring. Tell me, children. U is equal to how much? Half K into X square. So same way as I was saying, this string is acting like a spring only, no? Now any string that is elongated for delta L naught, what is the elastic potential energy stored in the string? U is equal to how much? Half into K value how much, children? K value I told you already, Ya by L naught, and into X is nothing but change in length and whole square. Correct or not? So everyone must and should remember this formula at your fingertips. And also you can write, if you simplify slightly, one standard result will come, that is half into stress into strain into volume of the wire. Volume of the wire, what formula, children? Area of the cross section into original length, no? Wire is looking like a cylinder only, na? Say yes or no. Correct or wrong? So what is the product of area of the circular cross section and into original length, children? Volume only. So you can write elastic potential energy stored in the string is nothing but half into and stress into strain into volume, and into what here, children? Volume. Is my point clear? Very much clear, na? Should remember compulsory at your fingertips. Okay, everyone copy down very quickly. Shall I move the slide, children? Okay, okay.